Hey everybody, welcome to AP Computer Science A. I'm Jill Westerland. I teach at Hoover High School in Hoover, Alabama.
And I am Rob Schultz. I teach at Bellbrook High School in Bellbrook, Ohio. Welcome back for another day of AP Computer Science A live learning. And we wanted to kind of share our virtual classroom. So we also wanted to share a little bit of information that we know if you've been with us up to this point, you know all of this information. So so I apologize for the repeat, but we wanted to make sure for the ones that are joining us for the first time, just some of the information that we know about the exam at this point. If you haven't heard already, the exam is going to be broken into two questions, two free response questions. The first question will deal specifically with arrays or array lists, or both. It'll be 25 minutes with 5 minutes following the 25-minute section to upload your answers. It'll count as 65% of your overall exam grade. And then the second question will be over methods and control structures. So you'll be writing code to call methods. You'll use control structures, iterative statements, things like that. Both questions will include an open-ended question at the end, which, being honest, we don't know a lot about yet. We're waiting for more information from College Board. Our test, the AP Computer Science A test, is scheduled for May 15th at 4:00 p.m. Eastern Time. So if you're within the United States, you can see your time zone up there. If you are outside the United States, you'll have to kind of figure out your time zone. Everyone around the world will be taking the exam at the exact same time. So I know for some of you that means very early in the morning, late at night. You'll just have to figure out your time zone, but the exam will be 4 p.m. Eastern. Again, as far as the timing, you'll have a 25-minute block for question 1, and then as soon as that block ends, you'll have 5 minutes to upload your response, at which time you can't go back to question 1. Then question 2 will open. You'll have 15 minutes to answer question 2 with a 5-minute upload time at the end. And as far as other course specific information, College Board is saying that you are welcome to use a compiler. If you want to use something like Notepad or Notes++ or JGrasp or JDoodle, Dr. Java, whatever you might have, but you aren't required to. There isn't specifically an advantage to using one versus the other. You know, if you're like me and you have notoriously bad handwriting, you might want to use an IDE just for typing purposes to make your code more readable. But if you type slowly, then you might want to write and snap a picture of handwritten code. So, so those are some options. I also wanted to point out that it's an open book, open note test. So we will address that later as we get into the lesson and we talk about some things. As far as testing security, you can go to AP Central and click the link to AP Coronavirus Updates, and then click the link to AP Exam Security to see some of the details that they're offering. We've been told that there are a multitude of levels of plagiarism detection and security involved with this exam, and we've been told that College Board plans to take attempts at cheating on this exam very seriously. So as we have time to prepare for this exam, do the right thing and prepare to give your own answers. Don't look at this as an opportunity to work the system or find the loophole or however you want to think about it. Okay. If by some chance you can't take the exam on May 15th and you have a justifiable reason, there is a makeup test date and time, June 3rd, 2:00 Eastern Time. So again, you can kind of figure out your time zone in there. And then we've also included some task verbs that we're going to use from this point forward as we review for the exam, because we are in full on review mode at this point. So some of the keywords that we're going to be addressing are assume and complete and implement or write. As we get into the free response questions, those are going to be the key concepts or the key tasks that we're going to be working with. Okay, we are on day 4 of Array Week, and today Mrs. Westerland is going to take us through the development of a variety of algorithms using arrays, and we'll look at another free response practice question. And I think at this point, I'm going to turn things over to you.
Yeah, thanks. So just reminders, we're going to be sticking with our course focus, concept-based, syntax emphasis. I've uploaded some new notes that I took yesterday and maybe the day before when Mr. Schultz was teaching. So there are a few, I think there's 3 new things there from his yesterday notes and maybe Tuesday as well. So if you didn't have time to take your own notes, I would love for you to just glance over mine and then re-listen to the session and take your own. But one way or another, use that muscle memory of getting the material in. So on Monday, I talked to you about this analogy that I have with the ocean being like Java, because Java is vast and large, and it is dynamic. People can write a class, and it can be used, locally, globally. Um, and what I tell my class is that we're going to pretend like that College Board has scooped out a swimming pool size of water from the Pacific of this Java, and that's what we're swimming in. Today, we're going to take a little trip to the beach and do some swimming in the Pacific with a couple of things that are not included in the subset. You're welcome to use Java methods or items not in the subset, so long as they're not doing the work for you. And I'll try to point that out as we go, but it's never going to be a harm to you to know more about Java. So, but for the most part, until we get to exam day, we're going to be swimming in these 4 lanes that I have mapped out for you. And right now we have ourselves situated in the array lane. So today we're going to look at the algorithms that I hope you looked at for your Power Up homework last night. And you can see at the top, prior knowledge is you do need to know the things that we've already taught this week. Monday was about array creation and access. Tuesday was about traversing arrays. And part of that lesson covered some of the algorithms on the list. Yesterday was a wonderful class about the differences and the similarities between a traditional for loop and an enhanced for loop. So if you missed that, go back and listen to that, please. Today, our focus is on the 3 bullets at the bottom: identifying standard algorithms, modifying them, and developing algorithms. So as a coder that you're going to be able to customize the algorithms that you write. And a couple of words come to mind when I think about that. If you have paper, well, actually 3 words. If you have a piece of paper, I would love for you to jot these words down. We need algorithms that are efficient, that do what they're supposed to do in a timely manner so that they're not unreasonable. We need algorithms, hopefully, that are elegant, that that you'll hear those 2 words. And if you watch the video that we shared part of last Friday, you'll hear the different college professors on there talk about efficient and elegant algorithms that smoothly process. But beyond those 2 things, and superseding those 2 things, is the concept of reliability. If an algorithm does not produce for you the reliable result, it it's not worth anything, really. I mean, I always use a paycheck as an example. It doesn't matter how efficient or elegant the algorithms are that take my gross pay and produce it into my net pay. If they're not calculating the math correctly and it's shorting me money, that's no good. So I think if you have a job, you can, kind of go along with me there. So we're going to be thinking about efficiency, elegance, but reliability is what we're looking for. And you're going to be able to see that. So yesterday, I broke this topic page from the course and exam description. I hope that you did some homework. If you didn't, I would just beg you to do it and really delve into the topics from here forward, because these are the things that you're responsible for. Skills and learning objectives, so the blue and the yellow, those are action verb oriented. You, being the student, are intended to be able to perform that action. Enduring understanding are these overarching concepts that, after you finish taking computer science A, the goal is that you would understand these high level concepts. And then the last thing, over on the right, the essential knowledge category, those are the details, the metadata about the topics. And so you can see where I've got this oval box with, I don't know, curved edges. I don't know a way to say that. Rounded corner box. How about that? Around these algorithms. And there's really 2 more at the bottom that I shorted. My box should be larger. Between all these bullets, I don't know how many bullets there are, 3, 6, 7, 9 bullets, there actually are 12 algorithms that we're interested in. And so I'm going to take some time and break down these 12. And most of these, well, I don't know, about 7 of these are what we're going to be looking at today. So the first one, and this was covered on Tuesday's class, topic 6.2 about traversal, would be an algorithm to find the minimum value in an array or the maximum value in an array. So in Tuesday's lesson, you saw code that did that. You probably have been given code in Tuesday's folder. You've probably worked with that during the school year. If you haven't, I want you to. The next three are, three different algorithms in one bullet, and we're going to be looking at those today, finding the sum of an array, the average, and the mode. And mode is a word that means the frequency. So is there something in that array that occurs the most frequent? That would be what mode. Median is the other one that you may hear of. And if you're a stat student, you're rolling your eyes because you know this, like, breathing. Median is the same thing as average. So all right, determine if at least one element has a particular property. This one came up on Tuesday as well. This is sort of like I want to search for, a number. I'm looking for the number 12, in this list of 100 numbers. I'm looking for the word Jill in a big old long list of names. So that's really what that one is. You've seen that a couple of times. We've done that maybe last week with arrays. We've done that a few times already. The next one, determine if all elements have a particular property. I'm going to show you that one today with strings. Access consecutive pairs. So these would be where the array might have numbers that are beside one another that are the same. So 26, 26. And we're going to see that pop up in the free response that we're looking at today. I'm real excited about the free response that we're looking at today. It's on a topic that I like a lot. All right. Determine the presence or absence of duplicate elements. So this doesn't necessarily have to be consecutive pairs like side by side. So this would just be, does this array have more than one, you know, word, I don't know, Sunday, or does this array have one or more 17 in it or something? Determine the number of elements that meet a specific criteria. This would be real similar to determining if at least one element has a particular property, except if you notice, if we're determining the number of them that meet that criteria, that would be counting them. So if you think about when you do Control F in a document, part of when we run Control F on something, it tells us immediately when we do the Control F that it found 16 occurrences of the word whatever you were looking for. So Control F is solving a couple of these different problems or these algorithm types that we need. So let's go to column 2, and then I want to get you to think for a second. The next one, shift or rotate elements. This is going to be tomorrow's lesson. And we're going to be looking at tomorrow's lesson. Mr. Schultz is going to lead you through that with a sorting option and then also a free response in that way. And then the last one that I'm going to show you today is reversing the order of the elements. So in other words, say we have 1, 2, 3, 4, 5, and then we reverse it. It's going to be 5, 4, 3, 2, 1. So how do you make that happen in code? So what I want you to do is look at this list for a minute and think about, and I've given you a few. What are some times in life that we need these kinds of tasks done? I've got a few brainstorm. I'm going to give you just a second. I want you to think of one. All right, hopefully you thought of one. If you think about minimum or maximum value, is ever a need that maybe your school needs to run a report to find everybody who has the highest GPA or who has the highest GPA? Maybe you have the highest GPA in your school. So maybe from the second one, you're really familiar with what's the class average on this test, or what are my total points? And I'm going to get my total points and I'm going to divide by points possible, and I'm going to find out maybe my category average in this class. We've already talked about Control F works on this. Another one I thought of that comes up in real life is checking for duplicates, and that might be down here under this one. And if you use maybe some of the spreadsheet softwares, they even have tools for checking for duplicates, because there are times when we might have a list of 1,000 names, and we need to make sure that we don't have duplicates, because maybe we would have. One of the things that's not here that you may have popped up, and even when I said that list of 1,000 names, is sorting. A lot of these algorithms would be optimized or made more efficient if the array was sorted prior to doing the task. That's not required for today's lesson, but if you know how to sort from previous lessons, that came up in Unit 10 that we covered a few weeks ago. If you know how to sort a, a list or an array, then that would optimize a lot of these processes. Not all of these would need a sorted item, but there are a few, particularly presence or absence of duplicates. If you sorted the list first, it would bring like things together, determining the number of elements. So like I say, it's not going to be a part of what you see today, but it might be something that you want to write down to enhance the code that I'm going to give you. You can definitely make the code that I'm going to give you better. Here's a strategy that I would like for y'all to think about going forward. We're heading toward the weekend. You got one more lesson tomorrow, and then the weekend. It would be great if you spent some time. Write pseudocode for each of these 12 standard algorithms. And remember, it's like 9 bullets, but it's 12 different algorithms. Write out by hand what needs to happen with these. Comment or include variations on things that you see. Some of the things that I've talked through. Brainstorm test cases. Like, what kind of test case would you need to plug into finding duplicates or determining if all elements have a particular property to actually test that? Look at the Java Quick Reference for methods that pertain to these algorithms. You're going to see some of them today, and I'm going to show you some, or I'm going to tell you some that I didn't use that I know are on the Quick Reference. So you should be able to make mine better. Work by yourself or in collaboration with others. And the part of the reason that I put that on here is you know who you've been in class with all year. So reach out to your buddies, work together, seek some ways to use technology to meet and work on these together. You've got 12 algorithms, and this is a perfect opportunity for you to collaborate across the miles. And some of you might be watching this. I know Mr. Schultz has talked about the class in, is it Phoenix, Tucson?
Oh, yeah,
Yeah.
Phoenix.
Yeah, so they're together anyway, kind of watching our review session. So, hey there in Phoenix, y'all are already meeting together, so you could definitely form teams. And we're told that Zoom has a really cool way to everybody be in a Zoom, but then break out in pods. So, think about ways that you might could work together on these algorithms. All right, so here's the list again, and I've made it a little bit easier to follow. The things that have the blue check mark have already been covered by Mr. Schultz on Tuesday. That would be the 6.2 lesson. And the things that are A, B, C, D, E are what I'm going to show you today in JGrasp. I've also loaded it already in JDoodle. So if you're watching this along with us and you happen to have like you're on a computer or Chromebook, you could open a new tab and actually open the JDoodle. If you're watching it later than live, you could pause and open it up, whatever. Where I have the blue arrow, that you're going to see tomorrow's lesson. So our goal was that you see all of these algorithms in some way. So here is the shared link for the JDoodle code. It almost sounds like a radio station. What is it? IZ50. I can't see the end of it there. Yeah, IZ50. So if you want to open it now, go ahead and do that. I'm going to go to JGrasp, mainly because of just the way JGrasp outputs. I think it'll be a little bit easier for y'all to see. And if you didn't write down the JDoodle code, I've got it up here that you'll see in just a second. So here's the JDoodle code if you need it. If I switch too fast, jdoodle.com/a/1 capital Z 50. And the source code that you could open in any editor is in the shared folder. So there's just a lot of different ways that y'all can get to what you need to get to. So, so that's good. All right, I'm gonna have to move my this around so I can see. Okay, I'm going to try to make this make sense and show you the implementation of these different algorithms. So first of all, let me get past that. I had to build 3 different arrays in order to make test cases to show you that the running of these algorithms. And when you're working with this code, I hope that what you'll do is make additional arrays and edit the code and make your code, you know, snazzier and cooler than mine, and add some of the functionality that we've discussed as options like swapping or something. This is a baseline, and there's definitely other places to go. So the first array that I made is called an array of ints, and it only has 10 in it. We can obviously change that if we need to and throw out more. And I have all 10 of them being populated from a random number 0 to 100, because, you know, it's going to stop at the beginning of the 101, which is only going to give us through 100. If you don't want to have zeros in your array, you'd have to add a +1 out here. Then we have array of days, and you'll see why I picked this in a little bit, with Sunday through Saturday. And then an array with pairs, because sometimes this one doesn't throw, you know, consecutive pairs, and I needed to have a way that I could guarantee to test. So this array has a couple of 78s and a couple of 1s. So those are the 3 arrays that you're going to see happening. And then I have this long section of output statements, because at the bottom of this code, I have a whole bunch of different methods. So the first one that you're going to see is it's going to print out for us our array of ints. And I'm going to show you that before I click go. I also have turned on right now to print out the reverse order. So this is the last in the bulleted list to reverse the order of the elements in the array. So when I run my code, you're going to see the original 10 you know, random numbers, and then you're going to see that same thing reversed. And I'm going to have to scoot up just a little bit. Oh, let me make this a little bit taller. There we go. So my first array, my array of ints, is here. 10 random numbers between 1 and 100. And then here's my method to reverse the order. So I wanted you to see that it works. And now I'm going to scroll down and show you the code. Well, first of all, before I show you the actual method, I named the method reverse order. But in order to print that, I had to call it the same way that I call to print the other. To get it to print out the array, you've got to run a for loop to get it to print, because my method returns an int. So all right, let me scroll all the way to the bottom of the code. And if you're in JDoodle, you're probably 10 steps ahead. But here's my method down here. It uses a temporary array that works to create a new array, a temporary array based on my array of ints. And then it's going to use that a temp variable, or the temp array, to reverse the order, and it returns the temp variable. So that's the reverse order one. Do you have anything to say about that, Mr. Schultz? Speak up if you do.
Looks good.
As we go. Okay. All right. So I'm going to turn that one off. That way you'll be able to see how the others work. Yeah, feel free to. Did I do uncomment?
You did.
There we go. I did.
You know, I've been using JGrasp for 2 years, and I didn't know that that block and comment feature was there that you just did.
Oh, wow.
I learned something today.
I love that.
Okay.
Okay, so I'm going to leave this on. And what I did is I began to write this, and I'm going to clear this down here. As I began to write this code, I just started building in output statements to just kind of test things as I was going. And I did a few things, you know, like now it's going to print my array again with new random number. There we go. With new random numbers, and then it's going to tell me position 9. And of course, every time it populates, and see, like right now I have 2 2s. So this will be a good one that we could test. Does it have multiple elements? So we don't always have to see that one. I just began to look that up. Okay, so now let's look at sum. What is it? Sum, average, and mode. And I've at first kind of cheated when I was doing average, because obviously the average is going to be the sum divided by the length of the array. So I'm going to show you average in two different ways. So here's my sum method, and it's really just going to iterate through the array, and every time it iterates, it's going to add to and increment and redefine. And this is from Unit 2. I looked it up this morning. It could be Unit 1, but I believe it's Unit 2. I'm pretty sure it's Unit 2, where you learn to increment and redefine sum. So sum is continually getting added to every single time it gets swallowed up. So it would be like 66 plus 8. And I'm not running this one right now, but if it were doing this one, 66 plus 8, then plus 2, and 18. So that was sum. Well, so after I made the sum, and I'm going to scoot back up, I'm not trying to give y'all a headache. I just have got to either turn these on or off. Okay, so here's my sum. And after I did that, I realized that all I needed to do for average was take the sum, and you can see it right here on line 32. I'll turn it on so you can look at it. But then I realized that's kind of a cheat, and that may or may not work well on a free response question. Because I already had the sum, all I had to do then was divide it by the length of my array. Mathematically, it works, but if you were asked on a free response question to write a method to find the average, this would not be a method to find the average. So let me run this real quick, and then I'll go down and show you what average is supposed to look like. This would work in the day-to-day world of, there's the sum and there's the average. All right, so now let's look at if we, I'm not going to be able to run it on the same one because every time it executes, it's spitting me out a new array. So let's look at average real quick, and then we'll go back. So average method is really just the same code almost as sum, except that when I get down here to the bottom, my return statement is to return the sum divided by length. I just made a new variable that populated the length of my array. So this will be a method to do the same thing that I did up above. And like I say, you've got these in JDoodle. Let me turn that on so y'all can see that run. And make them, pull them out, make them fancier, rewrite them completely. And if you get stuck, check this code. I mean, these are basic, so you can definitely go farther than I went. All right, so now what?
I was just going to say, like I said yesterday, one of the important things I tell my students is make sure you understand what everything does. As you take it apart, like Mrs. Westerland said, make sure that you can explain what each individual line of code does as you go.
Yeah. And you have a safety net, so it should be less aggravating, knowing that as you go through. So now let's look at mode, which is the most frequently occurring. And there are several different ways to do mode. I mean, there's lots of different ways to do anything. But this one happens to have a nested for loop. And this is one of the algorithms, like the duplicate one. If you used a sorting algorithm inside this method, you wouldn't have to have the nested for loop. You're not obligated to know that, but if you're going to keep a little list of things that I could learn between now and May the 15th that will ramp me up, learning to write a sorting algorithm to put things in order, lowest to highest, would be useful. So maybe what I could recommend is rewrite this algorithm, but sort the list first in ascending order, and then count the mode or the most frequently used items. So let's see if we run it. Had I turned it on up there? We'll see. Yeah, so I had. So here's the list. Now, notice what happened. It gave us back index 0 because there aren't any duplicates in this list. So we're going to run it a few more times and see if we get lucky. Still don't have one. We got one this time. And the reason we have one, and I know that we had at least something that occurred more than once, is because it didn't give me index at 0. So if we look down at this method, It's going to iterate through a couple of times, and it's going to return the start if we don't have a count to give back. So that's helpful. So that's mode, and you can tweak mode. I had actually written a different one that was a tweak on mode that actually counted the things that mode found, but there was kind of no need. So maybe you could add that to your little list of variations of these, because what you want to do is take these 12 as your basic and then think about brainstorming variations on them. All right, so this one I wanted to do strings and get out of the number game, and I wanted to say do all of the strings in the array of days end in Y. And the reason I'm testing that is because we already know the answer. And you know, some of y'all are listening to us in Spanish or Indian. I don't know what Indians speak. Maybe Hindu. I can't remember. Um, or Hindi maybe is the language. I don't know. So maybe in your language, every day of the week doesn't end in the same letter. So you could tweak this to get a different result. But I decided to make this, I think it's a Boolean method that will determine if every word in the array ends in Y. And obviously you can change it into names and not days of the week. So, all right, let me scroll down. Okay, so here's the determine if all elements have a particular property. This is what the CED says. Write a method to determine if all elements have a particular property. And I got stuck thinking about odd numbers and even numbers, and I knew we would do that with modulus. And I wanted to do something with strings. So then I thought about days of the week. So it's a Boolean, and it's going to return true unless it gets kicked over to false. And if you'll notice, this is where we're taking a trip to the beach and we're out of the swimming pool lane. I use char at, or you may call it car at. That is not in the Java subset. It's not on the Java quick reference, but it is usable. You're welcome to use that to easily look for elements. We could have done the same thing by using the overloaded substring and having to get it to split characters, but char app made cleaner code, so I decided to use that. So remember I told you a minute ago, if you're starting a list of little side things to learn, you know, swap algorithm is going to be one, sorting ascending would be another, and now you may want to add char at to the list. And I'm going to give you one more today that you might want to add to your list. And unless you've got, you know, 8 AP classes and you're crazy busy, you have plenty of time to work on these things. So, so this is what's going to return. So let's see what happens. Remember my array was Sunday, Monday, Tuesday, all the way out to Saturday. And oh, it's still throwing my other stuff. Let me get up where it'll turn on that array. Sorry. Maybe I don't have it where it prints out. Let's see. I don't think I do. It just does the test. I don't have it where it prints array of days. So that's something else you could add. You could add code to make it print your things in your array. And like I said, you could change it and put in people's names, Bobby, Kathy, you know, whatever names end in Y. And you could test it that way and throw in one that doesn't end in Y and see what happens. So that was my particular property. And now we're down to the last one I want to demo for y'all, which is count consecutive pairs of elements in an array with pairs. So this is where I'm using a different array. I'm using that array with pairs which I made using initializer list function. And I'm going to roll up so y'all can see it first. And we could change this. I just made sure that I added, so we could add here another 62. We could add out here on the end, you know, an 8 or something. It's looking for pairs that are consecutive so that they touch one another. So let me go down and show you the method, and then I'll run it. And where is it? Right here. So this one is a Boolean as well. It's going to look for, it's using a nested for loop. And again, we really can't sort this one because you don't want to mess up the integrity of the method or the result by sorting it. So you're going to probably have to do a nested for loop in this instance. And I got to talk fast because we got a really cool free response to get to. And we have not that much time. So it found that there are 3 consecutive pairs in our array, and let's go up here and look. I think that's right because I added another one. 62, 78, and ones. So there you go. So play with that code and work through these algorithms and make them your own and make them cool and better than mine. That would be awesome. All right, so now let's look at, oh, this is my fun fact. Can y'all see that? Can you see that, Mr. Schultz?
Yeah.
Okay, good. This I stumbled upon the other day. It wasn't new to me, but you don't think about it all the time. Y'all been using public static void main string args all year long. And since we're on a week of arrays, I just thought it would be cute for you to point out, in case you've never thought about what this really means, that the main method is really just a method like you've been writing other methods. And the parameter of the main method is a string named args. You could actually name it anything you wanted to. If you wanted to start naming it your own first name, I had a guy a few years ago. We called him Aubrey Senior in our class, but that's a side story. And he began to call his string Aubrey for the rest of that year. So, because he just was funny like that. So, okay, switching gears. I feel like we need to get up and do the hokey pokey or something to clear our brain. But we're going to switch to the free response 2009 number 1. And I'm excited that this is the free response because it has to do with a dice roller. And I start the year every year, and this was random. I didn't know that this was the one that we had picked for today and tomorrow. But I start the year every year in A and principles with dice roller projects. And so, point number 1 is in the world of standardized testing, the word die or dice is a slang word for a fair-sided number cube. So an actual name for a die is a fair-sided number cube that it would fairly roll any number at a particular time. So I have given you code in JDoodle. I've got to add it to the share drive. I forgot to put it there for rolling a random number in with random.random is die 1, and die 2, I think, is math.random. So if you're interested in learning, this was the 4th of my 4 suggestions, how to do something outside the subset, learning to use random.random might be something you're interested in. A lot of people who are programmers like random.random better for generating random numbers, and you're welcome to do that. So I've shared that with you. I would love for y'all to code this problem tonight. It's not complicated, and you've got a dice roller methods to generate your die. Your toss is what the problem is going to call it. So let me set up the problem, and I'm calling them JW Sparkle Notes because y'all like to use Spark Notes about other things. But the premise of this free response is that a die is to be rolled n times, whatever that n would be, and each roll is collected in an array of integers named cube tosses. So if you're a stats student, this is in your wheelhouse already. In part A, the array is declared and created, and it uses, you're given this toss method that you are to assume. Remember those verbs from the free response that you're to assume. You're given this toss method, and that's what I've given y'all in JDoodle, and I'll put the source code. I call it roll die 1 or roll die 2, but it's the same thing as toss, so you could rename it. So essentially, it's going to generate a random number between 1 and 6 because that's what's on a die, and it's called to fill the array. So we're going to get this array, and we're going to fill it with a bunch of dice rolls. In part B, the array that is created with all these random dice rolls is analyzed to look for the run. In other words, how many times did we have a streak? I think that's what y'all call them. I forgot which social media uses streaks, but anyway, it would be like a streak. How many times did I roll a 2 in sequential order? How many times did I roll a 6 over and over again? So that's part B that we'll look at for tomorrow's warm up. So here's the question, and I'm going to quickly go through this. I've already explained it. So here's just showing you a sample run, a sample array where it's been filled with all these random rolls. And a run occurs when we have like 2 5s together, a whole bunch of 2s, couple 3s, and when you have these streaks occur. Here is the toss method. This is what I'm telling you is the same as my roll die method that I've given you either in JDoodle, or I'll give you the source code for it. But you can write it. It's just like math.random times 6 plus 1, or you can't do times 7 because you could do, I guess, but you need to get it out. You don't want everyone to 0. So the bottom of the page for the first part of the question is this restatement of what part A and part B will be. And I have to hurry. So here's what we're going to look at with part 1. Write the get cube tosses method that takes a number cube and a number of tosses as parameters. So it's going to take in the cube and how many of these tosses we want to make. Like I want to roll the die 20 times, or I want to roll the die 30 times, and you'll see it down here in the middle of your screen. And you're supposed to write the code to, I don't have any lines, sorry y'all. You're supposed to write the code to populate the array and fill the array with a number of tosses. So let's look at the code for this. First of all, what do you think you're going to be doing first? I'll give you some hints. First, we want to declare an array that's going to hold all of our tosses. So here's the code to declare an array to hold our tosses. All right, now we're going to need to iterate through this array, and so that should ring a bell, and we're going to fill it with the use of the toss method that we were given, or roll die. So there's our iteration, and here we're going to call this toss method, which is going to fill each index with a random number from 1 to 6. And we're going to return that array that we received. So that's part A. And I didn't really give you time to do it because we're running out of time. But I'm going to assume you would do great. All right, so part B is your power up for tonight. What you're going to do with part B, and I would love for y'all to code this. Use the code I've given you and code it up. Part B, you want to look for the runs or the streaks. So first you're going to need to build your list. And then you're going to want to write code that will look through your list for times when a 2 has a 2 after it, and another 2 and another 2, or then maybe they have, 6 6, or maybe they have 1 1 1, or whatever the case may be. So we've already looked at A, then you're going to do B. All right, debrief. Here are all the algorithms that we've been interested in this week. Mr. Schultz is going to do tomorrow's. And you will have been exposed to all 12 of these. You've already been exposed to 11. We've got one more left, and then we're also going to be looking at insertion sort tomorrow. All right, take it away, Mr. Schultz. I've talked enough.
Here is the tip of the day. Okay, as Mrs. Westerland said, our goal is to make sure that you have a good understanding of logically how these algorithms work. So the tip of the day is to take some time and write the pseudocode for the algorithms for the first half of the algorithms that we've talked about so far. Determine the minimum and maximum, compute a sum, an average, or mode. Determine at least if at least one element has a particular property. And if you're not comfortable with the term pseudocode, basically it just means you're taking a piece of paper and then pencil and pen and you're writing out the steps. It could be in English, it could be in whatever your natural language is, depending on where you are. It could be in Java, it could be a combination of both, but it's not code, it's pseudocode. Okay.
Yeah.
All right. As we talked about yesterday, start thinking about creating your at-home workspace. I kind of took what we talked about yesterday to heart, and last night I totally redid my workspace, so I have a much more comfortable space now to work. I'm looking out a window, and so there's a link provided from Mrs. Westerland where you can look at some suggestions for creating your own workspace, and make sure you share your pics on social media at #myCSAWorkspace or myAPWorkspace.
Nice. And here's the link.
Okay, let's see. Here's the link for the power up. So tonight for your power up, you're looking at free response question number 1 from the 2019 exam, and make sure you focus on part B.
And I really think y'all can code that. to be
Oh, I
honest.
think so too. Yeah, I think
Mhm.
so too.
Mhm.
And then, as always, we like to end with some pictures of our pets. I know we started several weeks ago with a pet theme, and that pet theme has kind of carried on. So, so welcome to all of the pets and their owners that are joining us from all around. We've got Virginia, Louisiana, California, and Illinois
Yeah.
in the house today. So,
Yeah. Coast to coast.
yep. Okay, if by some chance you were in a situation where you're having access problems, either internet or device issues, please reach out to College Board and let them know. College Board has partners who have teamed up with them to help and make sure that you have access to everything that you need to be successful as we start getting closer and closer to the exam. And boy, we cut it right down to the wire today.
I know.
We are at exactly the 45-minute mark. So
Yeah.
thank you all for joining
I
us,
know.
and come back tomorrow. We'll talk about one more of these algorithms, and we'll hit insertion
Yeah,
sort.
and guess what you're going to see tomorrow? Alice. So all of you folks, my friends who love Alice, come on back.
And
Mr. Schultz has a surprise.
if you don't know what Alice is, well, you'll have to come back tomorrow and find out.
That's right. It's not a person. It's a coding language.
All right.
Bye, everybody.
Everybody have a great day, and we'll see you tomorrow.